BluntCut MetalWorks, October 30th, 2021. In many of my video, you can that refer to the word strength and also hardness. Let's define what it is. At strength, it actually is a resistance to a degree of freedom. So for hardness, say measure in Rockwell, C-scale for example, is a resistance of displacement. In other words, the indenter go in, and so they resist the indenter, the material from spreading outward. So that is a degree of move away. So that is hardness in terms of Rockwell, in terms of the indenter viewpoint. And the other component is the resistance to rotation, or how stiff it is. Resist to deflection, or the lateral move, rotation. And so an edge, that you can say the wear mechanism, it actually consists of two things. If you easily deflect, then you can have roll or chipped because they are lateral. And the other one is wear from the abrasion, the material being smushed inward or downward, and also part got abrased away by abrasion. So that will. So therefore, at stability, it consists of these two things. You require edge strength. And yes, for the wear resistance, where they are carbide, and that also based on how strong the first component, the displacement it is. If you can easily smooth in, say the carbide got squished in, and the carbide or got pushed and rotate or twist on the side, it will break. So either way, thing will fall apart. So the carbide will get fleck away. So on that level. So in the context, see the edge strength of the MagnaCut 64 Rockwell. It has the first component, right, the Rockwell. But however, the lateral, it lack off. And that's why you can see among here, between a 64 Rockwell versus 63 Rockwell CPM 154, I have 63.5 of it. And now even a 65 is similar here. These dozen, it got deflect less. And so the roll, say all these things here, is much smaller. Because again, they deflect less. So in other words, it's stiffer. In other words, it resists the rotation more. So that's why in this context, the damage, so you can say this is wear or damage here, is substantial for the MagnaCut here. So in other words, edge strength, again, two components. MagnaCut lack of the second one, the rotation one, or the deflection part. But it has the hardness in terms of for compressive or displacement. And even though, this is at 12 degrees psi, and it increases to 15 degrees psi, and compared to, say, like even the racks at the much more acute angle here, the damage is still substantial here. Because again, this thing here, it got deflect. Well, because it's too thin here, then they end up with deflection to a certain extent, and that is fracture. You see? But however, because it's strong enough in terms of strength-wise, it actually resists further damage. But however, again, for this 64.5 Rockwell, 15 degrees psi MagnaCut, it's still the apex on the edge itself. It's still lack of the second component, which is rotation. So anyway, so when talking about edge strength, keep in mind that two components of displacement and rotation. And so, but in the end of the day, if in the context of edge tool, this edge strength, I mean, I'm not going to the actual carbide itself here. I'm talking involved, but the carbide is, if you have a big carbide, for example, I mean, I will go a little bit here, it's on the very apex there. You can see, you can try to squish it in downward, or you can push it sideways. You put it sideways, that carbide is going to flake away. Therefore, you end up with a little hole, right? Or they could even got a whole bunch of things surrounding, matrix around it, flake apart. That way sometimes you have a little tiny half moon fracture or chip in this case, because if the very thing on top, on the apex, is the carbide, then that carbide, when they fracture, they take a chunk along with it. But anyway, so keep this in mind. This is what edge strength, that's what I meant, and also not that I meant, but I think it makes sense for in the general term in terminology. Rather than a lot of time, got people very focused on the hardness, but naturally, for edge tool, both of these things are equally important. Of course, if you have a really soft hardness, then of course you end up deflect a lot easier too. I mean, they link a little bit, but again, I mean, think of you have same hardness. I mean, a piece of something like say bamboo versus some sawdust, compressed sawdust, for example, to the same level of hardness. But yes, bamboo will resist rotation a lot better, and it won't break. While the compressed sawdust or whatever composite, they will just go to fall apart right away when you push it laterally. Thanks for watching.